you can deliver data center capacity that is 75% cheaper than traditional data center methods, 40% cheaper to operate, and up to 88% faster to deploy versus traditional brick and mortar data center capacities. Typical use cases for the performance optimized data center is adding additional capacity, is a disaster recovery facility, right? Some people will use it as swing capacity, and then for large scale out is also a very popular use of the performance optimized data center. So we have two major flavors of the performance optimized data center. We have the water chilled version, and we have the what we think of as free air cooled with direct expansion assist cooling. So the problem for most data centers today is they were designed 40 years ago, 30 years ago, and built 30 years ago, and they cannot handle the compute densities that we are bringing to them today. So if you walk through a traditional data center and you look at the racks, you're going to see the racks are basically 25% provisioned in terms of information technology. And that's because they can't provision enough power or provision enough cooling for the demands of current IT technology. So this is a huge waste when you think about the capital cost of a traditional brick and mortar data center, much less the efficiency of running that type of data center is extremely low. The way we measure efficiencies from a power utilization point of view for data centers is with the PUE, the power usage efficiency ratio. And that's the ratio of power that we provision to the information technology versus the amount of power we have to provision as a whole to the data center to have it operate. So most data centers today have a power usage efficiency ratio of 2.5 or greater. Bigger number, bad. Lower number, good, right? With the water chilled performance optimized data center, we can deliver a power usage efficiency ratio as low as 1.25. And with the EcoPod, the 248 pod, which is the free air cooling with the direct expansion assist, we can get that power usage efficiency ratio as low as 1.05. So when you think about that, traditional data center, you put $1 in for IT, and you got to put at least another $1.50 in just to keep it cooled and powered. When you think about a performance optimized data center, then we can put in $1 for IT and only 25 cents more in order to keep it powered and chilled. So that's huge operating cost efficiencies. A common commercial example would be the city of El Paso, Texas. They had a number of different disparate data centers that were inefficient, and they needed to rationalize that. They looked at all the different cost scenarios, building new, consolidating, and they chose the best solution for the taxpayer was the performance optimized data center. So they consolidated all their IT into the HP pod. Other example, University of California, Los Angeles, UCLA, they're using it for high performance computing. Of course, we have some very large scale out examples where a big search provider is using these and has these guys stacked too high and many deep in multiple warehouse locations around the world. So looking at the back here, this is our hot aisle access. Normally, of course, this would be on the ground, or if you had them stacked too high, you'd have a scaffolding system to access. We have redundant power dongles up there that you can see that has redundant power to each of the racks. You would also see that copper piping, that's simply a condensate drain capability from the exchangers, and then there's fire suppression. So complete fire detection and fire suppression systems are included in each of the pods, as well as security. If I look at the, here we have cipher pad access to all the doors throughout the pod. So complete integrated security as well. So these are the conduits for our two power access into the pod, so redundant power access into the pod. All the power transformation is in the back here, so if you needed to service power, you don't need to send an electrical tech inside the data center. They can be all serviced from the outside as well. Again, security, cipher access to those doors. And something else that would be of interest is the chilled water inlet and outlet up here. So you've seen the power conduits and the chilled water conduits. Obviously you have to have a chilled water plant and power capability to support the pod. If you don't have that, we can sell you the power pod. Okay? And the power pod provides a chilled water plant as well as UPS provisioning as well as power generation. So all the power conditioning, power generation, and chilled water function can also be provided in a 20-foot pod like that.
I have a question.
Yes.
A lot of people are talking about free cooling.
Yes.
And Canada is especially well adapted to free cooling. So how do you accommodate that in the pod?
Okay, so we have another whole pod model that I did mention earlier called the HP Performance Optimized Datacentre 240A, or what we call the EcoPod. And the EcoPod is essentially a free air cooling device. We would have two 40-foot pods, essentially in terms of capacity, with air handling units on the top that bring in the outside ambient air and cool the pod. If the outside air is not sufficient, we have direct expansion cooling capability to augment that, and there's an automated system to fully mix that and provide that efficiency. The great thing about the EcoPod is it has a power usage efficiency ratio of 1.05, which is outstanding. These traditional pods, water chilled, are 1.25. So the EcoPod can take advantage of cooler air and cooler ambient air that's available, and of course provide a much lower total cost of ownership. Thank you for that question.